recording, and we'll get rocking with this here. So welcome back. Final week. We're almost at the finish line here. I can't believe this is session number 7 already. Time's going by so quickly with this thing here. So what's on today's menu? Today's menu, we basically finished covering the real programming stuff. And we're going to just go and add in a couple extra little concepts here that are related specifically to games. We have some code that will help you out inside making collisions happen. So if you ever wanted to go figure out how to make 2 pool balls hit together, 2 blocks hit together, this is how you get it working. And we're also going to go and get some images added into the system as well. Images are an incredibly powerful way how to make something looks incredibly simple and have a lot of fun with it. First things first, so I just want to give you guys another application of software that's out there. And this one's a really cool one because it's pretty wild to wrap your head around that a computer can smell better than you. A computer can smell better than dogs, actually, the one that's being designed now. Dogs have some incredibly accurate smelling powers here. They can detect diseases and with myriad of a million other things. If you guys are dog owners, you'll obviously know this, but there's some MIT researchers out there who now applied machine learning to go and augment these noses, these digital noses, to go and separate chemical compounds that it detects and go and identify what those are even more accurately than how a dog's nose can be, which in my opinion is absolutely amazing that you can go and bring like the chemical engineering kind of family into the whole software engineering family. Anywho, let me go and move on to the rest of our stuff here. I want to quickly recap on functions just because that was a rather big and complex topic. And I think that this one's definitely worth mentioning again. So functions really come in 2 parts here. The first part is that you want to go and define a function. So let me just type up the regular from, zoom in as well. From processing, import star. We'll do def setup round bracket, colon, and we'll just put in my regular stuff here, sci 500, 500. Def draw round bracket, colon, and then we'll go background and we'll just set that to 0 or something like that. And then I'm going to type in my run command here. So function is a block of reusable code, and we get to use it over and over again. And we have used a lot of functions in the past. Size is an example, background is an example, print is another example of all of these things being different functions here. Functions, though, also can be created on our own, and this gives us the power to go and reuse code really, really quickly. So let's go and say, if we wanted to go and get a function to draw a circle at where our mouse is, circle at mouse, this is a chunk of reusable code that we get to use again later and later. And so what I wanted to do here is that you can basically pump in any code here. So I can type in ellipse, and I can pump in some arbitrary code, whatever I want, mouse X, mouse Y, 50, 50. And then in order to go and trigger this code here, it's currently sitting around. It's this chunk of reusable code, but I have not even used it yet. I want to go and call that function by punching it into one of my other sections like set or draw. So I'm going to go if mouse pressed, colon, I'm going to go circle at mouse, open round bracket, close round bracket. That's saying we're calling the function here. It goes and looks around and says, oh, here's a definition of circle at mouse, and it's going to go and trigger all this code. Last time I had this code placed underneath the whole setup section or underneath the draw section. This time I have it above. Honestly, it's only personal preference which one you like. The advantage of having it this way is at least you can read it and you can say, hey, this definition exists first and then you use it. I like to also use the other way around where this is my starting point. I read through the code, and when I find circle at mouse, then I jump to the definition here. Anyway, we run that code, and now we have a circle that goes at wherever my mouse is being held down. Let's say I don't want it specifically at my mouse. I want more flexibility with this link, so I can make this code be reusable in more spots here. What I can do is instead, let's go and add in some parameters. So I'm going to go x, comma, y. Maybe it's a good idea to rename this thing as well, maybe circle at coordinates, but I'll stick with this for now. Circle at mouse, x, comma, y. Remember, these are basically variables you're feeding in. You're not actually, they basically act like variables in here, but you don't have to define them. So I say ellipse at the x coordinate and ellipse at the y coordinate. And the cool part about this is if I go and fill, let's go and set this link to be red. Red, we'll set this original one stay or fill white, which we'll type in the fill command, and I'll set that to be 255. That's white. And if I want to have a red circle that's beside my first circle here, I can use circle at mouse. And now I feed in the X and the Y coordinates here. So let's see. I need to go and now add in some coordinates. My original one no longer works because it's asking for an X, asking for Y, and I didn't give it anything. So let's just go and put in mouse X, mouse Y as the parameters values that we're passing into here. And then over here, we can have some fun. And we can say mouse X plus 100, and then mouse Y. And what this does here, when we hit circle at mouse the second time round, the value of X up here is going to be set to the value of mouse X plus 100, reusable code with slightly different numbers here. And when I run that code now, I now have two circles that I can go and play around with. Does anybody have any questions about reviewing functions here? Anybody want me to recap anything quickly? All right. If you guys have no questions, we are good to go. Otherwise, feel free to just poke your mentor with a question and we will go on with the show. So after I talked about functions where we define the functions and we call the functions and we pass in the parameters, we have the function body. There's also the return value that I can quickly talk about too. So I can choose a random arbitrary example. This is not a great example, but diameter is set to 50. And if I choose my diameter here, and my diameter here, I can also return the return diameter. And what this does is tells the computer, hey, when I'm done my circle at mouse function, I'm going to go and return this thing. So I can go and store this thing at a variable. So I can say new diameter is set to the value of circle at mouse, which in my opinion, this is not a very great example. I just kind of whipped it up on the fly. But you can get information out of a function and feed it back up into your bigger functions you're drawing your setup on command whenever you need to. And that's the value of this here. So I can go and get the diameter to be printing 50 on there. And that's the value of the return statement. It's a heck of a lot more useful when you're doing complex calculations and you want to give back a number in those complex calculations. But that's okay. We've always talked about this last week and we can go and recap those when you need time. So I think I've already talked about this one too. Here's a better example of return statements. And let's go and talk about collisions. So collisions are actually another really, really simple topic, but this is one that's more specifically tailored towards game development or graphics. And it's not as important for like the general use of day-to-day programming. But since we are encouraging you guys to build games or whatever fun things you want, it's quite often to be extremely handy. A collision is a pretty darn simple idea. It's basically when you say you have object number one, little beanbag in my hand, and object number two in your hand here, and you want to go and say, when do they hit each other here? And when they hit each other, when do you want things to happen? A very simple example here is, let's say we have a bouncing block on the screen, and when do we want to ask, when does it hit this other block here? For anybody who's familiar with the game Pong, with all those moving around paddles and the little ball bouncing back and forth, you need to figure out your collisions for every single one of those hits. The math is not impossibly hard, but we decided that we don't want to teach you guys math class. We'd rather focus on a little bit of programming, so we gave it to you. But before I do that, collisions are all over the place. We have this idea of a bounding box. A bounding box, in quite short words here, is just simply a way to go and surround it, to recognize where the pixels are, basically. Because you guys have drawn a rectangle on the screen, but you need to now tell the computer where is that rectangle. If you have a character in a video game, you notice that if you played first-person shooters where you like run around with guns and stuff like that, you need to say, when does the cursor line up so that you can go and shoot the enemy player, or when does somebody shoot you back? Those are another example. You have basically a little wireframe box that surrounds the character, and that decides when they're being hit. And I'm going to say that they show up in so many different video games, maybe not with the exact name that we have, bounding box, but they still show up everywhere. For example, inside Flappy Bird here, if you guys remember that hit game from like, I don't know, 5 years ago or so, you got that bird that's jumping up every single time. And so he has a little rectangle around him to go and say where that bird is. And whenever he smacks into one of these pipes here, that's a collision. And that's when a game over happens. How about over here on Mario? I'm pretty sure that the beautiful platformer plumber here has a couple examples as well. Can anybody give me an example of what happens when Mario, his bounding box collides with one of these other bounding boxes on the screen? What's one of the things that happens? Mario flattens the evil Goomba in the corner there, the little evil mushroom thing. Yeah, exactly. When Mario collides with the Goomba, then he squishes it flat. There's another variation as well. When Mario hits the Goomba from the side, he gets knocked over instead because the Goomba kills him instead. Any other examples of what happens when Mario, one of these bounding boxes of Mario, collides with another thing? Right. So when Mario bumps into the question mark block, he releases the mushroom. When Mario hits the mushroom, he gets a power up and he evolves. So yeah, there's plenty of examples of when a character in a video game interacts with something, then something else happens. There's other examples that you guys might not have thought about as well. When does little blue box surrounding Mario hits the blue blocks on the floor here, he doesn't sink through the floor. He doesn't plummet down forever. He actually stops and lands on there. Same thing when he lands on that pipe over there, or same thing when he walks on top of these platforms here. There's concepts of what happens when he collides on the underside. He's going to go bouncing up and releases a coin, or he hits this mushroom from above. There's plenty of examples of where collisions are used and plenty of things that you can make happen when collisions happen with this. So we don't want to go and have to figure out how do you detect if two rectangles are colliding in the first place. We decided to go and give you guys some code to do this quickly. What I'm going to go and do here is I'm going to go and grab this little link in my chat here. And once it loads up, it already has some code that's ready for you guys to use. I'm going to drop that right into chat here. And everybody, please click on that. And you guys should be able to open up a brand new file here. Whoops. Hopefully without this JHK blah, blah, blah junk here. Maybe if I could save that, I can get rid of all that garbage. And so ideally, you guys shouldn't be able to mess around with my copy. And I'll show you real quickly. There is a couple files here. We got main.py. And this is all the regular stuff you're used to, def setup, def draw. But we also have from collisions import star. What the heck is collisions? Collisions is this extra file over here. We got a whole bunch of extra code inside here that makes it all a lot simpler for you to work with. And luckily for you guys, you do not need to understand what the heck it's doing at all. I have the save button up here because I'm the guy who created this. But instead, you guys should be able to see a little button that says remix. And when you click on that remix button, that gives you the ability to save this on your own so that you have this ready to go. Give me a thumbs up if you have that ready to go. You've got it in this link open. You typed in some code. So maybe you typed in hello world and then you press the remix button. Give me a thumbs up when you do that. Good, good. We got some people. All right. Just waiting for a couple other people to give me those good thumbs up. Okay, okay. I'll just give you guys 30 more seconds to hurry on up and get that finished. Once again, for those of you who need instructions again, step 1, open this link. Step 2, press the remix button in top right. Okay. I am going to go and wrap up right there, and then we're going to carry on. We now have a little chunk of code that's ready to go and help us out. And I'm going to spend some time, not with the code, funny enough, I'm going to spend some time making sure that we understand what the heck is going on with this link, so we know what code we want to be using with this. So I mentioned the idea of bounding boxes. There are going to be these little surrounding things around these rectangles, because fundamentally, one thing that I noticed a lot of people struggle to understand with this is that whenever we use the rect function or the ellipse function or anything like that, that does not actually give us an object and any physical thing to collide with. Rather, it's only just a painting. What we basically did, we had our little canvas here, and we took our paintbrush and we scribbled a rectangle onto it. The only thing is that it's just simply painting the pixels. There is no rectangle, it's a pile of pixels. We need the bounding box to say, now that we have a pile of pixels, we want to explicitly say that there's an object right here that you can collide with, and that when something hits it, something will happen. That's what we are going to be calling a bounding box for today's conversation. And now, what is a collision? A collision is a pretty darn fundamental concept when you think about it in these concepts of bounding boxes. So on my first diagram here, I have 1 and 2. They basically are two bounding boxes. I got bounding box number 1 over here, bounding box number 2 over here. And they're just simply a pile, or they're just a couple of coordinates in the computer. And when they collide, coming together, coming together, coming together, and oh, well, we didn't tell anything happened yet. All they do when they collide is they just magically start to phase right into one another. And you can see that into our second diagram. But intuitively speaking, you can actually wrap your head around, hey, when have these two things actually smashed into each other? The best way to describe it is when there is overlap on the pixels. You can see that tiny little shaded area in the middle represents when they have collided. So in our code here, we're going to quickly go and set up our bounding box. Like I said, bounding box is not the same thing as a rectangle, but it's pretty darn simple to go and create a bounding box of any size, and it's convenient to set it to be the exact same size as a rectangle. So let me get rid of this line here, and let me go down to our def draw. First things first, let me just go and show you guys. Let's go and fill this thing with some red, just so that we could see this thing. Red, and I'm going to draw my first rectangle. My first rectangle, let's go and set it at the coordinates of 100, 100, and then I will go and make it 150 wide and maybe 50 tall. Then, in order to go and put a bounding box on it, we're going to go bounding, or oops, I want to do something else first. I'm going to say my bounding box 1, BB1, is set to the value of bounding box, round bracket, and then here's the easy part. You take all these numbers here, you copy them, Control C, and then you go and paste them right into here. You can just use the exact same numbers, and we now have a bounding box. And it just looks like a red rectangle right now. And if you see that, that's perfectly fine, because the bounding box is actually invisible. It's only just that little dotted line that goes around there. You never see it around Mario because it's actually just quietly there the entire time. That's kind of boring all on its own though. So how about we keep on going? Let's go and see. Okay, bounds or bounding box 1 or whatever is just simply setting up the first one here, like I've shown you, bounding box. And you use X, Y, width, height. And okay, there's setting it up, and you put it inside a variable, just like what I got. Our slides show you the word bounds, but I call it BB1 because I'm a little bit lazy with my typing. And now here's the fun part. We got to go make a collision. And I'll show you that slide really quickly once I get some more code typed up. Let's go and get a blue rectangle, fill 0, 0, 255, and we'll go and call this thing blue. And we're going to say rect. I'm going to put this one to follow my mouse X because it's going to be pretty fun that way. Mouse X, mouse Y, and then we'll make this thing 50 by 50. When I do that, I need to also get myself a bounding box 2. BB2 is set to the value of bounding box. And then again, I'm just going to go and copy all of this stuff here. I'm just going to go and select that selection right there, copy it, and then go down here and then paste it. Or you can just type it out manually. It's honestly going to be just the same amount of work either way. And now, when we have that, hooray, we got some bounding boxes, and they're still not doing anything yet. Just because we have the bounding boxes does not mean they have collisions yet. So that's step 1, was setting up the bounding box. Step 1, set up bounding boxes to follow the rectangles. Step 2, make some collisions. And we're going to use that by using the collided function. The collided function is just a chunk of code that we have written up right here. Def collided, blah, 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 blah. A whole bunch of stuff here that you guys don't need to learn how to read. But the way it works in short is that we say if collided, and then we're asking it as a function. What are we asking to say if it has collided? Bounding box 1, comma, bounding box 2, BB1, BB2. And if they have collided, which is set to true, or if you're lazy like me, you ignore all that stuff there, you type in the colon, and then you can go and print, bang, collided. And then I'm just going to go and put right on here on the outside here, just for my own sake, so I can show you, waiting. And then I'll go and run this code. And let's see what happens. We got waiting, 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 bang, collided. And now this is a code here that can detect automatically if it has collided. Let me go and recap the pieces here that I've done. Step number 1, you have some bounding boxes that follow the rectangles. Don't worry about the fill. You guys know how rectangle works already. This is the most important line right here. Very important. And then of course, this is also very important. When you have the first bounding box and when you have the second bounding box, then you have set up your bounding boxes. Then you just have to take them inside a collided function. Collided will go and give you a true false return value. So you say with collided, test if its bounding box 1 has collided with bounding box number 2. If those two have collided, then bang, we have a collision going on. Maybe we don't want to go and print to the screen if they collided, so let me go and show you some other options. I'm going to rearrange the code because I've shown you the important parts here are just defining the bounding boxes, and we actually don't mind where the rectangles are defined. So, in fact, I actually like the idea of cutting my code so that those rectangles that I created up here are now going to show up underneath. So bounding box is just up here all on its own. And then we're going to do the same thing for this other one. I'm going to select these lines, the fill line and the rectangle. I'm going to cut that, and I'm going to go and paste it down here instead. Actually, I just realized a little typo on my end. The one thing I want to do with this is I am going to go and cut one more time, move it up, and I'll make it right before the collision. So the first rectangle happens before the collision. The second rectangle, here's where we have some fun. I'm going to set the fill color to be 02550 green, else fill 00255 blue. And with that, I can delete this line here. And let me show you what I just did. It'll be a lot easier to explain it once I get the code running. With this, I have a red rectangle and I have a blue square right here. And when I collide it, bang, it changes to green. Now I have something interesting that happens when I collide. As soon as these two rectangles overlap, they're going to change to green. And we can have some fun making some other interesting things start to happen with this. Let me review the code one more time, just so that it is much more clear what I'm talking about. I can delete this waiting line because it's no longer important to me. Step number 1 here, I'm going to set up some bounding boxes. So bounding box 1, bounding box 2. And notice those coordinates are still matching those rectangles that I've mentioned from earlier. Here's that first rectangle, so rectangle 1. And then here, way down here is rectangle number 2. Those numbers just simply line up 1 for 1. I set the first rectangle to always be red. I said the second rectangle, though, the color depends on whether or not it has collided. If the collision happened between those two bounding boxes, set the fill to be green or set the fill to be blue. And it's honestly really fun just to have just that, but there's so much more that you can build into here. So here we go. Return value will tell us if they are colliding. So when they're overlapping, they have collided. We just throw them together and let's see what we can do with this. So with that, I kind of already spoiled it. I'm going to give you guys a quick question here to see how well you understand the concepts of the bounding boxes and the collided. You don't need to have typed out the code. Just show me that you've understood the concepts on here. So which of the following is going to be true for this? Let's open up the question. All right, people should be getting their answers in because we'll be finishing up pretty soon.
I'll just close it in 5 more seconds. All right. So it seems like option number C got 89% of the responses, which I think.
Excellent. Excellent. That is the correct answer. So great job for you guys out there. And you guys have understood the code. I think that the best way to understand the code is that when you see things like this, BB1 is set to the value bounding box and you don't really know what that is. That's hard to understand, but this is easy to understand. If collided is set to true, that's obviously going to be just a simple true false question here. In fact, I can go and show you something really cool. I'm going to, let me see, flip through my slides really quick. Here we go. This is an example that I was just showing. Bounds 1 or BB1, whatever name you choose, honestly, works just fine. You create them and then you check out if they have collided. If they collided, then you trigger off some code. I've shown you just simply changing the color, but you can make things like changing direction happen. So instead of following mouse X, you have it something that where you go X plus equals 1, X plus equals 1, and something like that that can march along. You can use that combined with the knowledge that you guys have for the other exercises to say when there's a collision, make it change directions. All this stuff down here, you guys actually should already know how to do. And the hard part was just simply understanding how to go and create these bounding boxes for that. So here's another little example on how to go and use bounding boxes for, making those things bounce back and forth. Previously, we had an example where a ball can go and bounce off the edge of the screen, but how do you make a rectangle bounce off another rectangle and change directions? Basically, all we have to do here, you see our bounding boxes, I have x1, y1, width 1, height 1. Instead of having hard-coded numbers, I have variables that go inside there. And these variables, of course, just match up with the rectangles that you see down there. So if you know how to draw a rectangle, you know how to create a bounding box. If you know how to make a rectangle move, you know how to make a bounding box move. All you have to do is copy the numbers. And what you say, when there's a collision, then change up the speed. And the speed is the thing that controls how to go and make these things move. So all this code down here should be perfectly familiar to you guys. And it's just those top 3 lines that we learned just now. So for the extremely curious and astute among you guys might be poking around as collisions up high, wondering, whoa, what in the world is going on here? Some of you guys might even be able to read this just fine. But for those of you guys who don't know how to read this thing, I'm going to give a really quick summary. You guys don't need to understand all the minutiae and details. This is just only a rather rapid summary. I'm going to show you inside main.py file again, back to our regular side here. I just wanted to go and pique your curiosity. What is bounding box 1? What is bounding box 2? If I go and print BB1, let me go and show you. Print what is inside BB1. When I run that code, I stop that, I run that, and I see, oh, that's weird. I see a list of numbers, 100, 100, 150, 50. Oh, what do you know? They exactly match up with these numbers here. Bounding boxes are just simply a list of numbers, but how are those numbers useful? Well, let's go and see it inside the code itself here. Basically, what we decided to do, we used to ask students to write this code themselves, decided that it's just faster to go and give them some pretty pictures instead to explain it. What we basically do is, if I have one bounding box rectangle and a second bounding box rectangle, there is no compare rectangles function out there. Instead, you have to compare raw numbers. So if we take a look just only on the x-axis right now, so no y dimension right now, just the x-axis, we can notice that if this left edge here, left 1, is lesser than right 2, so this far left edge is to the far right edge here, if the left side is lesser than that, and then meanwhile, the right edge, the middle rightish edge here, and the middle leftish edge here, if the right number is bigger than the left number, and hey, what do you know? You got a collision going on right here. Once again, you can actually just go and try it out with yourself. You have left, which is a very small number, and then you have right, which is a little bit bigger number, left, which is some number, and right has some bigger number. You can check out. The only time that they ever collide is when my 2 thumbs here overlap. And this distance here does not overlap too far, because if it's all the way out here, that's not a collision. This is a collision. This is a collision. This is a collision. This is not a collision here. So you can go and see that by comparing just 4 simple numbers here, you can actually go and create your own collision logic So if you ever wanted a challenge, you can try programming the X coordinate collisions all on your own. How about the Y coordinates? Surprise, it's actually the exact same thing. We have the top position and the bottom position, and we just have to go and check when those collide. And when all four of these collide, so left, right, top, bottom, when we have a collision in all four of these spaces here, then bam, we say that we have a collision. So in total, we say we have to go and compare 8 separate numbers here to go and check out if it collides. 4 for the left, or 4 for the first box, and 4 for the second box. And those bounding boxes functions that we have been calling right here, BB1 and BB2, all that does is just simply collect the numbers in a neat, organized spot. So it's easy for you guys to type out. All right, now I'm going to challenge you guys. You guys should be able to do this just fine. Can you guys create your own bounding collision here? Make a rectangle that follows your mouse along. And when it catches that little blue square in the middle there, tell me that you got a collision. For now, focus on getting the collision working. And then if you are having struggles of making that ball bounce back and forth, worry about that later. For now, the big important part is making sure that you can get that text. You got it. All right, let's take 15 minutes. Try this out. If you got that, then the only part left is just to simply make the ball move back and the box move back and forth, just like we've done in previous sessions. Anyway, I'm going to carry on to another really fun piece here. Every single programming language and every single tool has their own different unique ways of how to add images into their games and all. But processing makes ours way pretty darn easy, if you ask me. And all you have to do is just simply go and plug in a couple files to make it go and work. Images are fantastic for getting your backgrounds on there, some characters, adding some little bullet sprites on your screen, getting some coins for Mario to jump into, power-ups, etc. I've seen so many excellent applications, and I have to say, every game I've seen has been improved 100% as soon as they added a couple of extra images into it. It's amazing because it's only like 2 lines of code, and it gives you so much value out of it. First things first, though, you might be wondering, how do I get an image in the first place? Well, I'm glad you asked. The easiest way to do that is to be basically following along with me. Let me go and see if I can just quickly go and get an example here. So I'm going to go and I got a couple of images just ready to go sitting on standby. And we got a couple posted inside of our speaker notes here in case if you're actually reading along with me. But what I'm going to get you guys to do is just follow along with this one here. Let's go and get ourselves a nice little spaceship. So I got myself a link right there. If you guys go and click on that link, and then, oops, oh, I just clicked it again. And then you should be able to open up these triple dots here and press the little download button. And we got ourselves a file that's named it. Oh boy, that's not a very nice looking file name. What I'm gonna do is I'm gonna grab that file, whatever it is, and I'm gonna go and make sure that it has a very easy name for me to remember, because this name kind of sucks, I'm not gonna lie. And if you choose easy names, all lowercase, no spaces in them, it makes it so much easier to do your code. I'm going to call mine Spaceship right there. So again, for Windows users, you just have to go and right click that, and then you should be able to get a rename button somewhere. Here it is. On mine, that's rename. Windows users can press F2 to get a keyboard shortcut. Mac users can press Enter to get a keyboard shortcut to go and rename that thing. And for those of you guys who notice, mine has .png added on the end there. That's just simply because I have view file name extensions turned on. As a programmer, I found that especially useful. You do not need to bother with it right now, but it is important to remember. This is a .png file, so we want to hang on to that in a little bit more. Once I finish renaming that, I'm going to go and take my spaceship.png, and let's go over here into my code. And here we go. I got Ignite Collisions template, the code here. I'm going to take my spaceship.png, drag it, drop it, and oh, that did not work. That's because I'm sorry. I thought this thing would automatically do that, but I'm wrong. Instead, the easiest way to do that is go up here, click on this little view and add images button here. Let's see, we have to go and press the plus on the image library, and let's go and upload a new image here. And now I can drag and drop it because I skipped a couple steps. So now we can drag and drop. We got our spaceship added in. You guys can use spaceships, you guys can use players, you guys can use whatever you want to go and get your file loaded in. So now I have spaceship.png that's ready to roll on here. What I can do is start using it in my main file. I want to go and first things first, load it up. So what I'm going to do here, I'm going to go and create a variable. Oops, not right here. I'm going to go inside def setup. Yep, we're going to make some code inside setup for once. Not very often we need to do this, but I'm going to go and say global spaceship. If I can spell spaceship properly. And then down here underneath my size command, what I could do is set the variable spaceship is set to the value of load image. Once again, that's load capital I in image. And then I need to go and give it a string. The string here is going to be the name of the spaceship. So I'm going to go spaceship.png. Yes, you do need the PNG here because the computer needs to know what kind of file it is. Quite often, whenever you do file name extensions for any programming, you always have to include the extension type on there. There's only a couple rare occasions when you don't need that. Once we have loaded up our image here, the final step here is to actually go and draw it. So I'm going to go and use the same global spaceship. Global spaceship. And I'm going to put that inside my draw code here. And now this way, after the background command, I can just go and use this just like a regular rectangle, but with one extra rule. Image, just like that, round bracket. So that's image, round bracket. And which image would you like to use? Again, you're going to go, oops, round brackets I don't think are necessary. And you know, it's faster for me to just double check right here. What we need to do is now pass in the spaceship that we just set up. So we're going to go as image, spaceship, the variable, no quotes required around it this time. And then you just go and specify the X coordinate, the Y coordinate, the width, the height, just like as if this was a rectangle. So maybe I want to make this link follow my mouse X, make this link follow my mouse Y, and I'll make this 100 pixels wide and 100 pixels tall. When I go and run this code, there we go. I have a spaceship. I can go and get following around and have some fun with that. You'll notice that it is in the top left corner of my mouse here. So if I wanted to go and bump this over, I can go and say the mouse X minus 50 and then the mouse Y minus 50. And using that, I should be able to go and center my spaceship right on the center of my mouse. So how many of you guys can get a spaceship drawn on your screen? All right, we got one person. Who's next to get a spaceship drawn on their screen? Okay, we got some more people. Looking good, looking good. We got some more spaceships rolling along. Excellent. That is fantastic. We got more people getting their spaceships. I'm gonna wait for just a couple more seconds to get you guys, the rest of your whole space armada ready to go, and we'll go and blast some alien bugs. Okay. Just a couple more seconds. All right, what I'm going to do, I'm going to show you guys one more example. This time, I'm going to do it a lot faster. Let's say I want to add a background onto here. The process is identical. So if you lost track on how to do it first time, I'm going to show you again how to do it with a second image here. So I got a second image ready to go. I'll paste it into Zoom chat, but you can use whatever image you'd like. And this is going to be a nice space background here. Once I open up this file, I'm going to go to the download button here. When it goes and downloads, I'm going to make sure I rename it to something nice and easy for me to remember. So let me just call it space, because I'm not feeling very creative. And I'm going to make sure that the file name extension is going to stay there just the same. That's because I have the file name extension checkbox turned on. That's just me. Anyway, after that, I'm going to go into my code. I'm going to press the image icon right here in the top right. And I'm going to go and drag in a new image. So I'm going to drag my space.png, pop it into there. Loading, 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 and loaded. Okay, when I am done with that, I'm going to go back to main.py. I got global spaceship. I'm also going to go global space just in the background here. I'm going to go space is set to the value of load image, quote, space.png. And then I'm going to go to my draw section here. Now that I've loaded up my image, I'd like to draw it. I'm going to go global spaceship, and then I'm going to also go in global draw. Just add that in. And what I'm going to do now, I'm going to put this right by the background. I'm going to go image, space, and I'm going to set it to fill up my entire screen here. So x coordinates, y 0, y coordinates 0, width 500, height 500. And when we run that, there we go. We have a whole galactic background for us to go with. And that's how you can go and add in images. Of course, you can use any tools you want. You can draw your regular rectangles instead if you prefer that over your images. It's all up to you. And luckily, images is a very fast topic for me to teach because I don't have very many complicated topics. You just have to go and memorize these things. Of course, I'll go and show you one last trick if you want to go and add in your own images. So let me go and just quickly look up player model, or if I go and search up player or something like that, I can go to images and there's a lot of things I don't think looks very good. So maybe I'm going to go look for player sprites. These are quite often pretty good to look at, but I don't want to have a crazy background here. Google Images gives me the tools button, and I'm going to go color. I'm going to pick transparent, and then here's one. This one looks like it's inspired by Pokemon. I can right click that. I can go and save image as, and then I can just call it player.png, and I can repeat the process all over again. So that's just a cool little tip. The Google Tools has a quick way to get a transparent background, which looks so much better. And my phone's just lit up like the 4th of July, trying to read what I just said. Anyway, I want to go and give some extra time just to go and talk about projects. The final projects, we're finally here. So the projects are optional. You guys don't have to do them. But if you do, we're going to give you guys 250 Ignite points for the projects that you go and submit. We are going to mark them based on 5 categories here. Readability means how good is your code here? How nice does it work? Efficiency, making sure that your code is not doing some crazy things that it shouldn't need to do. Novelty, how creative can you guys be? And if you guys are programmers, I know already that you're quite creative people. Functionality, so if it's like feeling good, how many features can your guy do? Can you make it jump like this guy as an example? Complexity is going to be the last part, like how interesting, how involved is it? As long as it's not really, really simple, you guys get a lot of points for this. It is up to our judges to go and decide on this. Anyway, I got a link here for the rubric, and you guys can submit as many projects as you like, as long as you have different projects. And of course, we have a deadline coming up, which is going to be set to August 25th. I'm looking at my calendar right now. August 25th is 2.5 weeks from now. So that is some time to get some serious code done. Just keep in mind that you don't get to build everything huge. So I don't want to see anybody trying to reinvent all of Elden Ring. You're not going to have enough time for that. And then we have the submission form. Our regular submission form works for submitting your projects too. Anyway, we're on Discord. You can ask us here, but we're going to also give you some space on today and on next Thursday. And if you want us to post your project on Instagram, just let us know. Pop your name into or pop your Instagram handle on, and we'll go and post that thing, which would be super awesome. Of course, you guys get credit for it because it is your project after all. And so, that's not supposed to say next week. That's supposed to say on Thursday. Session number 8, we're going to be playing a Kahoot game just as a review for everything. And then we're going to go and work on our projects. And so here we go. For today's exercises, we only have just one exercise because we want to give you some time to go and build up your games too. So use this time. I recommend using this time to talk to your mentors and figure out, A, how do you build this game or little thing right here? Or B, how do you go and build up a game? Talk to your mentors, get a plan for what game you want to build and try it out. I really recommend you guys build a game because it's honestly so much fun. And I love looking at everyone's submissions. With that, I'm going to let you guys get going. Approximately 30 minutes for this. If you guys have any questions, feel free to stick around here right before you go to the breakout rooms. Otherwise, see you guys in the breakout rooms. Can we team up for the projects? I think that historically, yes, we have allowed teaming up. I'm going to get back to you on that once I get confirmation from the rest of our team. Thanks for the question. Daniel, I see. Oh, yeah, Daniel, I see you're still here as well. Do you have a question? I guess not. To our Discord chat, and I'll put it into Zoom chat as well. If you guys want to go and just find some extra images, we have a whole bunch pasted right here. Or you can just search them up on the internet, and that should work fine too. Just make sure whenever you are submitting your project, you also go and share your images as well. So a good way to go and check is to try opening up your project in an incognito tab. So you just press Control Shift N on Windows computers and Mac computers. I think it's Command Shift N, or you just go up here in new incognito window, and then you go to your trinket link.io/python/blah, blah, 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 blah. And you just check out that, make sure that images work. The worst thing possible is that you try to share a game with me and you forget to share your images, and I'm looking at just blank images everywhere. Other than that, the project, I did get a question and I do have confirmation now that, yeah, teamwork is a dream work. If you want to pair up, I'm going to allow groups of 2 at maximum, or you can just group and work solo. That works fine as well. And yeah, you guys can work on it together. That is totally allowed. With that, I will catch you guys on Thursday. That will be our last formal session. And then these projects will be due on the 25th. It is optional, but I highly encourage you guys try it out and show me something cool. If you need some project inspiration, just go play some games or go take a look at some of the things you want to look at. They do not have to be games. You can build anything you want, but it has to be in Python code. So we have to be able to run it on Trinket. That's everything from my side. If you have any questions for me, let me know on Discord. Otherwise, let's go and answer that poll. And once you answer that poll, you guys can head on out.
I think we have everyone answered.